Yes. Today we're looking at behaviors of polynomials, of the graphs of polynomials, how they act. They're going to do numbers of things possibly, but when they get through doing all the things in the middle, what do the ends do? And so we can trust what that looks like. In behaviors, we're going to look at functions that are even, and that where the function power is even. So we're familiar with that. We'll also look at x to the fourth, x to the sixth, x to the eighth. We want to look at even degrees and see what they do. Now, like we knew that, let's talk about the quadratics, which we're most familiar with. We knew that if it opened up, what would that a be? What would that a value be for that polynomial if it opened up, where the right-hand side or the left-hand side was going up and the right-hand side was going up? What would that look like? What would that a be? Yeah, that's right. It would be positive. We learned that a long time ago. The a would be positive. This coefficient in front of it would be positive. That's what happens when you have a quadratic of a degree of 2. If it's positive, it opens up. What if this happened to be negative? That's right. We learned that it opens down. Guess what? With all these other even polynomials, the end behaviors are exactly the same. If a is positive, the right hand and the left side are going to be doing the even things, the same things, just like a quadratic. A fourth degree polynomial has end behaviors that are the same. If one end opens up, the other end's going to open. And what opens it? That leading coefficient. If this is an x to the fourth polynomial, if a is positive, what are the end behaviors going to do? That's right. Just like the quadratic, they're going to open up. If that coefficient is negative, what are the end behaviors going to do for a 8th degree polynomial? That's right. They're both going to go down. So even powers, even degree polynomials, their end behaviors are the same. And this leading coefficient tells you where they're going, just like we learned with quadratics. Well, let's talk about odd degrees. That means we have polynomials where the degrees are odd, like our linear, or x to the third, or x to the fifth, or x to the seventh, and that goes on and on and on. Right? What do those end behaviors look like? Well, let's talk about our linear. Our linear is a straight line, right? And if the left-hand side was going up, the right-hand side goes down. If the line's like this, this is heading up, then this is going down. And so the end behaviors are odd. They're different, right? If one's up, the other's down. If one's up, the other's down. The ends act oddly, not the same, different. So that works with all these odd degreed polynomials. Now, let's talk about the coefficients. We learned that when a, or the slope, was positive, how did the line look? That's right. As you're reading a book from left to right, that's going to open. Now, I'm not sure how the camera's looking, so if this is, what it is the right side, if it's positive, the right side rises. You're running uphill from left to right as you're reading a book. And if this is left to right, if this is left to right, you're going to be going uphill as you're running, right? That's a positive slope. This is a negative slope. If this is left to right, it's a negative slope, and you'll be running downhill as you go. That's what we learned with linear. Well, guess what? That happens the same way, whether that's a cubic function, or a 5th degree, or 7, or 9, or 11, or any odd degree polynomial. If the coefficient is positive, the right-hand side rises. The left-hand side falls. When this coefficient goes negative now, it just flips that, just like the slope of a line. Traveling downhill, negative. That leading coefficient is going to have the left side rising and the right side falling. That's it. That's really a long lesson about those end behaviors. We are the Ask Academy of Polynomials.